It's your boy Nate and Dan.
Hello, starting with example 2.B.1. Given link OA rotates with an angular speed of omega OA equals 3 radians per second with a counterclockwise sense about pin O. At the instant shown, link OA is horizontal, AB is vertical, and theta equals 36.87 degrees. First, let's locate the instant center IC AB for link AB. Why don't we just find all three instant centers because there are 3 pins? So we know that since these 2 pins are fixed, these are going to be instant centers. IC and IC. This takes care of link DB and OA. Now, for link AB, we have to determine the velocity at A and B and find where they intersect at a perpendicular in order to find the instant center. So which way is A going to move? What's its velocity? Well, it has to be perpendicular to its instant center, so it's going to move this way. Now, which way is B going to move? Well, it also has to be perpendicular to instant center at D. So it's actually going to move perpendicular, just like such. Now, we need to draw perpendicular lines to these velocity vectors and see where they intersect to find the instant center. Let's do that. Perpendicular of A, and then perpendicular at B. As you can see, they also intersect at point D. Thus, the instant center of AB is at point D. Now, with part B, we have to use the location of the instant center, and we have to determine the angular velocities of link AB and DB. So let's start with what we know. Let's start by finding the velocity at A, VA. That's going to be equal to the velocity at O plus omega OA cross R A/O. So we know that the instant center is at point O, so that means this velocity at O is 0. We know what omega is, we're given that in the problem, and we can figure out this distance, R A/O, by looking here. It's a distance of L, but it's A with respect to O, so that means it's going to be a positive L. So we know that VA is equal to omega OA cross positive L, and that's in the I direction. Omega OA is always in the K direction, so we know that that's K. I'm just going to write that here. And we know K cross I is going to give us a positive J, so we know that the velocity of A is equal to omega OA times L, J. And we know that omega of OA is equal to 3, so we know that the velocity of A is equal to 3LJ. Okay, so now let's see what else we can do. Well, we know the velocity at A now. Let's find the velocity at B. Okay, so that's going to be equal to, just like this equation above, just change some subscripts around, velocity at A plus the omega of BA cross the position vector RB/A. So we know VA, and we're solving for omega, or eventually we want to get to omega, but we need to find VB first. So we know the position vector, that's also given here as L, but it's B with respect to A. So it's actually going to be a minus L. So we'll go ahead and plug that in, and we'll substitute 3L J hat in for the velocity of A because we know that's what it is. 3L J hat plus omega BA cross, we know that is negative L, and that's in the J. Likewise, we know that omega BA is in the K direction always, and we know that K cross J gives us negative I. But since we have a negative L here, the negatives are going to cancel out, and so we're going to be left with 3L J hat plus L omega BA I hat for velocity at B.
from this point, we're now going to solve for the velocity of b again, but now with respect to d, as we do not know velocity of b or the omega of a and b. So we're going to do the same formula as above. The omega db cross r b slash d. And then same process again. V of d is going to be 0 though, because it is our instant center. And then we're going to our rb slash d. This is a little bit more complicated because it's not just a straight line anymore, or it's not directly on our I or j axis. So we have to calculate what this distance is here, which we have found that it is tangent theta of L. So we're going to put that the tangent theta of L is in our I direction, and then we just L down of J. So now substituting all that in,
Whoopsies.
we're going to get omega of dB cross, it's negative L, tangent theta, because we're going from
D to
D to B. So both of the values are negative. And then doing that cross product, we'll get omega dB L tangent of theta J and negative L omega dBi.
That'd be positive though.
Yes, positive. So that is equal to VB, and now we just set both of our VBs equal to each other. It's going to be a beautiful equation.
Illustrious.
That's an I value as well.
You're right.
So now what we're going to do is we're going to set our i's and j's equal to each other, so that way we can... Oh, we also have an L in every single term, so we're going to cross that out. And then we're going to set our i's and j's equal to each other to find both omegas dB and BA.
Oh, these L's are gone. Whoops. And then omega.
So first we're going to solve for omega of dB in our j direction, which is just going to be three. Oh yeah,
What? Whoops.
3 over, yep, tangent of 36.87. We get that omega dB is negative 4 radians per second. And then we find that omega BA is the same as omega dB, therefore omega BA is also negative 4 radians per second. And those are both of the answers for example 2B1. Thank you for watching.